Ladies and gentlemen, hello, sir. I am honored to stand before you today as we gather here for my presentation, Object Detection and Classification. My name is Muhammad Aiman, and I have the privilege of serving as your presenter for this occasion. As you can see here, this is the poster that we create together. Credit to Siti Nur Aisyah for making this poster. So we start with introduction. Our project focuses on leveraging basic image processing and machine learning techniques to enhance road safety. We aim to develop a reliable code capable of detecting and categorizing road hazards and vehicles on the road in real time, such as potholes, puddles, damaged roads, and cars, buses, and pedestrians. And one more thing I want to add is another obstacle on the road, such as animal and also bottle. The objective here is to develop an accurate and efficient object detection model for cars, lorries, motorcycles, potholes, water puddles, and cracked roads on Malaysian roads. At the same time, we want to optimize the system for real-time processing. And lastly, we want to evaluate and improve the system's performance. This is the methodology of deep learning. And we all know that deep learning come from the improvement of basic image learning and machine learning. Without these two, there's no deep learning. First, we need to have image dataset, then pre-processing image, and then we classify the image, and then we can detect the object. As a result, for basic image learning, we use to detect signboard on Malaysian road. For machine learning, we want to detect the car or vehicle and also pedestrian. For deep learning, we want to detect the obstacle on the road, such as pothole, animal, and also bottle. Conclusion, we may see a considerable improvement in accuracy in the results when the code for fundamental image processing, machine learning, and deep learning are each performed individually. So what I want to say here is every method have their own weakness and strength. Okay, so right now, we want to focus on problem and analysis of the CV method, template matching, machine learning, and deep learning. So this is what the problem I encountered during coding this method. First, basic image processing, sensitivity to variations, lighting, rotations, scaling, and occlusions can all affect how well templates match in a bad way. Another problem is limited object variety. When the signboard being detected have limited visual variety, template matching performs well. If the objects have a wide range of visual characteristics, template matching might not be appropriate. Machine learning, limited robustness in difficult situations like daylight, significant occlusions, intricate road constructions, hard cascades may have trouble accurately detecting vehicle and pedestrians. And the most famous problem for machine learning is false positives and false negatives. In some cases, hard cascade can result in false negatives, finding features that resemble vehicle when there are not any, or false negatives, failing to find vehicle in the image. Last one is deep learning. The problem with deep learning, as we know, is high data requirements. To attain high accuracy, deep learning models need a lot of level training data. Example, pothole dataset collection take a lot of time. Another one is interpretability. Deep learning models are frequently regarded as black boxes, which means they are difficult to understand. It might be challenging to comprehend how and why a model generates particular predictions. Example, sometimes the cat recognized as dog because the color look similar. So right now I want to show the basic image processing first by using image. This is the result for basic image. As you can see, my train image is using traffic light sign and stop signs. And I use homography method to detect the object. Both of these working well. This is by using phone to capture in real time. The reason I do not use real time in this video because I have already used Teams, so it might be lag. As you can see, this is the result of detecting the object. This is the train image I use. And this is basic image processing in video. This is my train image. And this is the result. Okay. So already finished basic image processing. Now we go into machine learning. This is for image by using Cascade. This is the result. As you can see, Cascade can detect pedestrian, the red box, lorry, and also car. The accuracy is quite high in this case. This is what I captured for real time by using Cascade. This is near UniKL. As you can see, this is pedestrian, and this is car, and car here. This is by using recorded video, by using Cascade. Okay, already finished. This hard cascade detect car, lorry, bus, van, motorbike, and pedestrian. Lastly is deep learning. For deep learning, I have two codes. First to detect potholes, and the other one to detect many objects. For many objects, I can detect pothole, water puddle, bottle, cat, cow, dog, potted plant, traffic light, and many more. And the pothole file for deep learning is to detect pothole only. So we focus on pothole first. This is the result for potholes in Selangor. And this is the result. The video by using deep learning. Okay, already finished. This one for many objects. First, we focus on image first. This is the result by using deep image to detect animal. First is cat, cow, and lastly dog. And the accuracy is quite high. This is from real-time video that I captured from my home. It's the bottle. As you can see, the accuracy is 96%. This is the result video by using deep learning. Okay. So far, we already finished all the method to detect the object. So right now, we focus on analysis of the result. For basic image processing, when it comes to accuracy, results may be precise if the template is distinctive and representative. However, the accuracy can be impacted by changes in the illumination, perspective distortions, occlusions, and scale variance. The good thing about basic image processing is execution time. The template matching process can be completed quickly, but if the template is used at various scales, the time complexity may dramatically rise. Another one is machine learning. The good thing about machine learning is efficiency and speed. Hard cascade-based detection algorithms are noted for their quick inference times, which make them appropriate for real-time applications. The program runs by looking for certain features that define roadways while scanning the image at various scales. Machine learning can improve the accuracy with enough training data. The system can learn to recognize road features with high accuracy given enough positive and negative samples. The higher your training data, the higher the accuracy. And lastly is deep learning. When it comes to accuracy, deep learning is very high. Deep learning models in OpenCV can detect objects, recognize animal, identify vehicle, and detect pedestrians with high accuracy. And the good thing about deep learning is real-time performance is quite good. Deep learning models built with OpenCV may frequently attain real-time performance, making it possible to process video streams from cameras quickly and effectively. So, as a conclusion, the accuracy for basic image processing, I can say, is about 60%. For machine learning, the accuracy is about 75%. And lastly, for deep learning, the accuracy is about 90%. That's all from me. Hopefully, you understand and enjoy this presentation. Thank you.